Hello, everyone. Welcome. And today this is the Transformative Vertical Fly Working Group, Public Services. Of course, our invitation goes to all working group members. And this is a milestone meeting. This is actually meeting number 100. And today is Thursday, September 25th, 2025. I'm going to briefly introduce our speaker, which is me. So for anyone who doesn't know me, this is Johnny Du. And the topic I'd like to talk about today is titled Compound Vertical Takeoff and Landing Aircraft, Unconventional eVTOL Design with Diverse Use Cases. So with that, I'm going to move to our regular session. There you go. Okay. Now, if I can make the page advance, I'll be in good shape. There you go. All right, that works. All right, as usual, I'm going to cover a few coming meetings and conferences. There's a Asian Australian Rotorcraft Forum in India. It's coming in November. And we have the Vertical Flight Structure and Survivability Technical Meeting, which is a virtual meeting in October 21st, 22nd. And of course, there's a European Rotors in Germany, in Cologne, Germany, in November 17th, 20th. And of course, AirTech. Some of you probably have been there. It's in Germany. It's October 22nd and 24th. And of course, there's another one in December in Thailand, the Third International Conference on Advanced Air Mobility Systems. And the important one, just make sure everybody put on their calendar and make travel plans, the Transformative Vertical Flight 2026 in San Jose, coming up in January 27 to 29, 2026. And I think we have another meeting Danielle, you want to brief us on that?
Sure. So, Vertical Flight Society and High Sky, the Vertical Flight Society's commercial air transport group, and High Sky are doing a joint webinar on October 9th on STCs. Mike is organizing the speakers. If you're part of that group and you attend those meetings, it's still the same link for you to join. And I don't know, is there anything else I'll stick the link in the chat for it. So for some context, we just wrapped up an aircraft certification course, and there were a lot of questions on STCs. So we'll do a joint webinar and break that down. It's free to attend, open to everybody. If you see a thing that says RSVP, you don't have to RSVP if you're already part of the other webinar, but that's kind of like for our people coming in. So yeah, please join us. And I will put a link where you can RSVP and also get access to the High Sky community, which I also want to say we're advancing hydrogen aviation, but we're going to add to our slogan, batteries included. It's not just, if you're hydrogen curious, you're welcome there.
Very nice.
Andy, anything you want to mention about that?
I think the word on the street is there's going to be free beer, so it's worth showing up.
Yeah. Here, there's yours.
Yeah.
Yes.
Virtual beer. Okay,
Yeah,
I'll go for
virtual
that.
beer. Yeah, we're really thanks so much, Andy, for hosting the event. Even though it's High Sky that's organizing it, it's not particularly about hydrogen. It's more about how do you get an STC, like some of like Harbor Air has for their battery and electric motors through Magniacs, how other customers would use a supplemental type certificate to be able to fly a certified aircraft with a different type of propulsion system or whatever. So yeah, and just I was I was a lecturer for the certification course, and I explained what STCs were, but there are still a lot of questions. So I figured we'd have an hour discussion on that. And Danielle, maybe you could put the survey link in there as well. So I'm now on the board for High Sky. So, we're looking for more educational opportunities. High Sky is a nonprofit charitable education society. So we're trying to educate people about aviation, not just hydrogen, but aviation and advanced air mobility. So take the survey on what you might be interested in other types of courses. Some, there's different cost models for different in-depth lengths. So
It's a very short survey.
yeah.
Also, thank
Two
you,
questions.
Andy. I'm so sorry. I didn't even mention you. I keep getting confused on which group is yours and which group is Johnny's. So yes, thank you, Andy, for supporting us with this joint webinar.
Oh, well, it's great for everybody. And as you both kind of alluded to, when we're testing new tech, we don't want to do it all at once. We want to isolate it using certified and known technology as the platform, and then our new testing, our new devices we're testing to be added to that. And the STC is a great way to do that for testing, and then also for rolling out products. So I think we're going to talk about that among other things, and it's just right on topic for our crowd.
Good deal.
Cool. Yeah, we're looking forward to it.
Yeah. Thank you. Thank you very much.
Oh, sorry. One last thing. Flying High, our third annual Hydrogen Aviation Conference is November 5th. It's virtual this year. And it's one day, November 5th. And I will give you the link to that. So please register. And I do have a discount code that I will stick in the chat for VFS members.
But I think the non-discounted rate is $30.
It's only $30. Yeah, it's very affordable.
Yeah, it's practically free, and it is free for students.
Yep.
Love the user-friendly settings you guys have. Thank you.
It's all about education.
Yep.
There you go. Yeah, I'll go for that. All right. Hey, thank you guys very much. Very important information. Make sure you all joined if you can. All right. With that, I'm going to move to the main topic today. So please feel free to interrupt, discuss. This is preferably more a dialogue rather than a pure presentation. So this is what I've been working on for a little while. It's a weird-looking thingy, but we call it compound eVTOL. What it is a counter-rotating main rotor on the top, provide a lower disloading to enhance the hovering capabilities. And the main rotor is simplistic in the design in that the minimum or no mechanical actuators and so on. It's mainly the motor controls system. And there's the rest of it almost like a ducted quad rotor. And because it's a smaller diameter rotors counter-rotating in each duct, actually, they can respond to the RPM control much faster than larger rotors. And so we're kind of relying on this smaller quad rotor type arrangement using this simplistic, almost like a drone type control and command and control, and leverage the low initial rotational inertia so that we can respond in gust conditions fast enough and so on. And if you look at the blue part of the structure, that's kind of like a skeleton thingy that carry the load from the front thrusters to the aft thrusters and to the main rotors. And the fuselage part is designed to be interchangeable modules for different missions and different purposes. And it can be a skid, it can be wheeled, because one of the function we're going to test is it can be a short takeoff landing vehicle. If we have a little runway, the thing can charge down the runway, almost like a yeah, the main rotor provide 80% plus lift, and with forward velocity, will take off in very short distance. And I'm not going to read through all the details and wording, but we kind of talk about the overall ideas and concepts. The the main rotor are not that big in diameter. There's a reason for it. It's transportability for some of the missions like first response, disaster relief, and so on. We liked it to be able to, like the two-seater version, we liked it to be able to shove into a cargo container and just ship anywhere and put it out and fly away. Same thing that, because of the size and limitation, we enable the design to be able to put on the trailer, just tow to wherever we need to deploy it and let it go. So that's one of the reasons why it's a smaller in the main rotor diameter. And also, we're a bigger cord. And so we're able to generate the lift we needed at the lower tip Mach number, and so as to control the total, the shipborne noise, which in some operations, the noise would be sensitive and critically important. So it's a balanced act in the design. I would definitely not say this is the perfect design because we all know all design is some kind of trade-offs, but the design is trying to tailor for better hovering capability and efficiency. So in some missions, if we need to hover for a little bit to pick up people in the water, this may be a little bit better. Definitely not as good a hovering machine as traditional helicopter. I will never claim that, but it's kind of in between functionality and capability. And for certain use cases, this may be a viable configuration. And of course, we try to not just design one. So we laid out the plan for, at least for now, 3 different sizes. If you use the seating capacity as equivalent, it's a 2-seater, 4-seater, and 6-seater, leveraging the similar technology, similar concept, similar system. And hopefully the flight technology control systems developed for the 2-seater will be able to carry over to the 4 and 6-seater with limited modifications. And it took a while, but finally got the pattern approved by the U.S. Patent Office. That was a learning experience for sure. And some of the features that we try to incorporate into the design, it's one of them we think it's kind of important. It's a multi-purpose vehicle. It can be passenger carrying, air ambulance, firefighting, cargo, transport, tourism. We think having if we incorporate those capability early stage, we were able to respond to the needs, the market demand properly. And it is environmental friendly. It's designed to be all electric battery. Battery is at the bottom of the fuselage. Actually, there's intended to design a layer of stainless steel sheet at the bottom between the battery and the passenger cabin. Kind of borrow the concept of a standard firewall design on the aircraft certification aspect. And the battery is removable, modular, removable. Doesn't mean we have to do that every flight, but in case of an emergency response and so on, out there in the disaster field, removable battery, even though it adds some weight to it, but the service maintenance is easier, and we can put it out, charge it up on the site, and shove 4 of the new ones in, and we can turnaround time can be a lot faster. So that's a trade-off in the weight, a little bit of complexity, and the turnaround rate. Of course, high reliability is an important design feature. Try to minimize any mechanical system complexity. We do have the tilting thrusters, so that is a mechanical system. But it's autonomous, designed so that it's minimum operator required. Actually, hopefully, most of the people using it is a operator or pilot, not pilot, or passenger, and the system can be programmed to complete a mission even without a pilot. And of course, we can have an optional piloted vehicle in some cases due to certification requirements and so on. That may be necessary, but the system will be enable that. But it's really a fly-by-wire, so even if we're called a pilot, it's really control the vehicle with auto landing, auto takeoff. You're putting the waypoints and target locations, and you will provide hopefully building detect and avoid system to have a safe operation with really the pilot is more like a train operator. And of course, we have on the top of the vehicle, we have a space above the baggage area tailored designed to house range extender. It could be a hydrogen energy system. It could be other kind of power unit, internal combustion engine, whatever. For some mission that requires willing to trade the payload to the weight to the range, that option is included. Just try to show what we really try to accomplish here. If you look at the fuselage, it's not that compact. Of course, I admit this is not a fair comparison. I'm using a 4-seater for comparison, and the other ones are 5-seater. So, okay. So I have to clarify that. But if you look at the size of the vehicle, it is intentionally make it compact so it can get in and out of the like within the urban streets, landing in a 4-lane intersection, whatever. If we have a problem that need to get people to the hospital, we can go land in the small openings and pick up the firefighter, retrieve them to a safe zone. So we kind of think it has some benefit if we can keep the overall operating size small and compact, make it more transportable, deployable. And of course, as I mentioned, we try to make it to be able to accommodate different missions. Obviously, carrying people is it's without saying, but it can also be able to carry a medical transport a patient or land in the side of the road in a traffic accident, somebody needs to get to the hospital or care center as soon as we can. It's not big enough, especially the 2 or 4-seater, to perform the same medical transport as some of the helicopter. Fully equipped medical helicopter, it's not intended to replace those, but rather filling a short-range, on-demand, quick response time type missions. Here are just some of the preliminary specifications, so you get a feel for the size and the weight of the vehicle. And it has a pretty limited power system, and on this one, I'm using a pretty conservative, actually throughout the whole data set, pretty conservative assumptions on the current battery energy density. Like in this case, I use 225 watt-hour per kilogram. I know we already can get safe enough, fully protected battery system better than that. So you have to bear with me that this is performance-wise, it's a pretty conservative number. And as battery technology continue to enhance, safety continue to enhance, the number will just keep getting better. And that's one of the benefits of the removable battery modules. As we have the battery cells and packaging get better and better, we don't have to completely redesign the aircraft to take advantage of it. And this is what the 2-seater looks like. Yeah, the most left-hand corner is what it looks like. The thrusters are facing up. I'm also like flying a drone with the 70-80% of the lift taking care of the main rotors, and it controlled like a drone, like a quad rotor. And the in-flight, cruise flight, the thrusters are tilted to 80 to 90 degree, take out the most, so most of the thrust came from the thrusters, not from the, so the vehicle flight level. You don't operate as if it's a helicopter. You don't need to tilt the nose down to fly forward. Thruster take care of that. And the seating on the two-seater is slightly offset. For one reason, if this keep the vehicle small and keep the second row seat a little bit more legroom. And there's another reason I'll show you a little later. And here's a four-seater sized and preliminary spec. It's a little bigger battery, double the battery size, and it's the calculation space on a 250 watt-hour per kilogram battery system, based on the expected timeline of development. And that's, again, what it looks like. The seating is a very conventional four-seat, two in front, two in the back. And the door actually is one of the harder thing. And I knew that from my aircraft design background, that door is pretty difficult to design. You want it to be light. You don't want it to twist around in the wing. You don't want it to flap open. You don't want to hit the main rotor. And yet, when you close it, you want to feel like a Mercedes door that with this solid feel. But I have to admit that that is one of the challenges we have. I think is probably true for most of the airplanes. Is a door system, and you want the people to be able to get in and out very comfortably without crawling difficulties and so on. So, anyway, just a little side note. And this is the sizing of a six-seater. Again, it doesn't have to be seats in there. It could be carrying cargo, carrying other things. It could be better equipped medical transport and so on. But it's just bigger and with even better battery systems. And that's what it looked like. The seating is a little bit different. It's a one seat in the center in the front, and side-by-side seating with space in between, and then the three abreast seating on the back. Of course, kind of like most SUVs, you can fold the back seat down. The back side is where the baggage bay is. I'll see if I have a picture later to show what that looks like. But that's where the baggage go in from the back. But if the third row seat is fold down, now all of a sudden, if you're going to the airport carry for a long trip, you're going to have a lot more you need a lot more baggage space, based on my personal experience. And typical timeline how many years it would take, I do not, I won't say that as a guarantee, but it will be easily 5, even with the program today, with all the industry better developed than we started 10 years ago. I think the timeline can be more compressed than some of the early starter because of the better supply chain development, better technology, better certification experiences, and so on. So that may be a famous last word, but that's a possibility. And of course, one of the important part is what we're trying to do is look at all the required steps and process to take it all the way to product delivery and design. I keep saying the system will be designed for producibility, for certification, for operation and service maintenance. Make sure those are incorporated upfront so that the down the road process will be much easier and in-field operation will be more practical, more usable, and the operator will be happy with it. And right now, we're just in the prototype quarter scale proof of concept modeling testing. The I will admit that, one time we overpowered the main rotor, and the render, it turned out to be way too sensitive in our control load, and we have a other than perfect landing, let me put it that way. But the next test, in addition to the hovering mode operation testing, performance, stability, mainly the control, the next step we're putting a set of floats on, and so we're going to do the horizontal mode, the takeoff, flying control, and the surface is to have the progressive control crossover as typical eVTOL that go through transition mode. The transition part is expected to be the hardest flight control programming and the dynamic simulations analysis and to get it right. Fortunately, that's one of the beauty about the quarter scale proof of concept testing is that on one of the tests that we have some damages and we were able to recover within a couple of 3 weeks. That's the beauty of the modern technology, 3D printing and everything. So that's where we are right now. And some of the use cases we kind of briefly mentioned, cargo logistics and medical transport and area tourism, urban air mobility. We always think that's going to be a large market in the medium and longer term. And of course, critically important application will be firefighting emergency response. That's dear to my heart. And some of the related topics about the eVTOL for public services. There's 6 SAE Edge report that talk about different use cases, challenges, what else need to be worked on, and so on. So anybody interested in dig into this aspect, if you want the link and so on, let me know. I'll send it to you. And here's one of the use case on the cargo transport. The system is designed to be a cargo module. What I show here is it's a 2-seater with a cargo module bay. It has a rollers similar to transport airplanes and so on the bay. You shove it in and it locks it down and you fly away. And when you get to where you want to be, you put it out. It's not what I call the last mile. It's not door-to-door delivery. This is more a last/middle mile transport from delivery center to distribution center, whatever. Or more importantly, maybe disaster or high-value product. You want to get from point to point. Again, this is not a long-range device, so it's but modularization could help speed up the loading, unloading, processing time. And this is the medical system version. If you can see, the back door opens pretty widely, and the vehicle is designed so that the floor height is just right for most of the typical stretcher. You can push it against it and push, the leg will fold and goes in there. Because the size, the current design is such that you can put the front seat to the normal position, and because slightly offset, there's enough room on the side to fold the stretcher vertically sideways. And so you can carry a medical personnel on board or first responder on board to the site or scene or locations, whatever. And then this person, take example, car accident, okay. Somebody can ride this to the scene, stabilize the patient, and put the front seat forward and put out the stretcher and loaded the injured person and shove it right in, and now it will fit in the space that we have allocated. Close the back door and push to the bottom. It flies and take it directly to the selected or closest or best suited Medicare center to be treated. And that's basically some of the key sizing parameter go into the two-seater design. And because it's so small, you can see that if we superimpose onto the parking lot, it really, anywhere you have a, 2 or 3 parking slots, you can probably land this thing. And of course, the fire truck, I mean, I look at some of the fire stations, and many of them probably could reinforce the roof and be able to land on the rooftop or landing on the ground. Many of the fire stations have a piece of land on the site and so on that we can probably easily make a landing pad for the eVTOL of this size. And if any of you don't recognize this is one of the picture of Maldives, and I think if I were to, which is on my to-do list, if I were to go there, I don't mind riding a 2 or 4 seat tourist transport devices. If you look at the map of Maldives, a lot of islands, they're not that far away from each other, perfect for this kind of platform. And it will be quiet. You can talk to each other, or the tour guide can explain to you what you're looking at. You can still hear without putting your headsets on. And of course, we'll see how fast and how big the urban air mobility, air taxi, or personal transport is going to look like. But this is absolutely tailored for that as well. Now, I'm going to switch topic just briefly about this. This is a global disaster fast response network. I've been working on this for more than 10 years, still working on it. This is a zone of high-risk disaster zones map. And what I've been proposing is a large wind and ground effects network that position at the several selected locations, pre-positioned, preloaded with food, water, medicine, response vehicles, and so on. We can cover most of the global disaster-prone areas. We can get to the response zone or disaster zone from gathering the people from the standby team to get the flight ready to go. In many cases, probably 12 hours. In absolutely anywhere around the world within 24 hours. That's the go. And that is the design concept. It's a medium large wind and ground effect machine. It's a 430-ton max takeoff weight, but it can carry 120 tons of payload. It's sized so that the current or near current technologies, the power plant systems, thrusters, battery systems. This is a hybrid system. Just battery ain't gonna hack it. This is a really powered by turbine aircraft, but it is sized to and designed to be producible. Can be developed, can be done, it's a practical proposal, hopefully. That's what it's going to look like. It can come in and land in the water. And you say, what does this wing ground has to do with the eVTOL we're talking about? And that's what it is, because once you get there, you land in the water, you can launch a hovercraft from the front. You can deploy a helicopter eVTOL from the back, and you can now get to the, this thing can be floating in the water as a command center. And has onboard hospital on the top deck, and the vehicle can come in and back and forth and bring in the food, water, medicine to this disaster area and bring the injured person back and forth. And this is a more of an illustration that another one is coming in. If you look at the back end, we have a truck, and it's a powered wing, augmented wing. So it can actually, with the thruster deflected downwards and with the air cushion system, the front fork are the inlet for the air cushion system. It allows it to get on the beach, not rugged terrain, but you can get on the beach and park there. So you can offload ground vehicles very quickly. And the back end opens up and become a flat deck. And if you look at where the eVTOL is landed on the flat deck, you offload the patient, you go straight in, and there's the hospital right in front. And of course, as illustrated on here, the eVTOL can go back and forth, perform the mission. And of course, as I said, it could be a helicopter, for the heavier payload, for longer range, and so on. So it's a combination of all kinds of mission-enabled vehicles that carry over by a few of this large wind and ground effect machine for the disaster response. So anyway, I just want to illustrate how the eVTOL can be used in such environment and conditions. I think that's it for now. I'm going to open the floor for any comments, suggestions, and you guys are all experts in this thing here. Am I totally crazy, or there's some useful features on this that may actually be usable?
Johnny, your brain has been busy, buddy.
Trying to.
There's a lot to unpack here. I want to give you some feedback on your aircraft. I love the design. You've got the enclosed rotors on the vertical and forward rotors are enclosed for safety and also efficiency, which is brilliant. They're out of the way of the side doors to make for easy exit and ingress. And I really like the back door. It reminds me of a BK-117, which is a really good EMS helicopter because of the ease of access in the back. You can't have somebody that's in a stretcher contort. You need to be able to slide them in quick and get them out quick. And your design enables that. So I really appreciate the thoughtfulness that goes into this. I was wondering your thoughts about the counter rotating mains. How does that? What's the effect of having both of them on with your aerodynamics? Certainly, you get a big bonus in not having to have the a tail rotor, which is great. But is it going to get pretty choppy up there, or are you still going to get enough flow that you get all the air movement that you need?
Yeah, well, thank you, Andy, for all the inputs. And the main rotor, the counter-rotating main rotors, the idea is, or the benefit, if you want to call it, is that because they are counter-rotating, you don't have any the lead. You still have the leading and retreating blade effect. Mike probably knows this way better than I do. But because they're matching, so they canceled out the rotor moment, and also because it's a rotating at the lower Mach number, try to limit the tip Mach number even at the high end 0.75. So so you don't, and the vehicle is not that fast, I have to admit. Okay, it's not a supersonic airplane. So that, we're not trying to shoot for the maximum forward velocity. It's more usability and total flow time, from mission, from siren rings and get to the patient, the time. So it's not a very high speed vehicle. So that limits some of the problems that we encounter with the main rotor. So that's the trade-off we kind of put in there. Also, it is designed so that it's not mechanical. It is the basic concept is two rotors, separate motors, and we can actually do a little yaw control with differential rotor if we wanted to.
Oh wow!
Yeah, but
I hadn't thought of that.
It has a lot of redundancy built into this configuration. For example, we try to design the motor so that the motor will have more than one winding system. So if you have one circuitry out, you lose maybe 1/3 of the power, and it still rotates. So then you can compensate with the other rotor. We designed a little extra margin in there so you can speed up the other rotor. But now you have a little differential torque, right? One is runs faster than the other one. It is designed so that in the vertical mode, we have what we call the vertilon behind each ducted fan. The vertilon can do differential deployment so that two sets of vertilon, when they do differential, it provides a yawing moment to counteract the differential rotor. Hopefully, if we size it right, even if we lose one main rotor altogether, we just power up the other one. By that time, I don't care about the noise. Okay, I just spin it up and it give me enough lift, and we land. Same thing with the quad thrusters. They have reserve power in the motor, so you can power up for 90 seconds, exceed the rated or continuous rated power for a safe landing. But so that anyway, so any one device that if we lose any one devices, we have enough control and power to land safely. That's the goal.
Love
But
it.
yeah, it's I know we try to pick up as much lesson learned from the compound helicopter that didn't get selected for the Army program, but the technology is there. The performance, the numbers seems to be quite good. So learning from what has been tested out there, even the last few years that work being done, it seems like we may be on the right. Actually, some of the lessons learned, useful data were coming from the Texas A&M on one of their competition. They designed a wide blade counter rotating, so we got some of the published data right there. So yep, still got a lot of work to do, but seems like possible.
Oh, it's fantastic. And I apologize, I had to jump off for a quick phone call, so I missed the part about whether this is a project that you're working on for your company, or is it a partnership with others?
Right now, it's a privately funded program. Yeah.
Yeah. Yeah.
Probably some kind of partnership is going to be needed to be realistic. We all know it takes a lot of money to to work on a project like this.
So much money.
Yeah, we're definitely open, but I figure anything I can do to contribute to the good cause, what the heck, why not, right?
Yeah. Have you been focusing on mostly the airframe and aerodynamics, or have you dipped your toe in the water on propulsion and energy storage on this project yet? Or are you agnostic?
Agnostic, however, in other words, we try to make it as modular as possible. In other words, like the main rotor, the motor itself. Okay, I've been every time I go to conferences and so on, talking to one of my hidden agenda was to identify and evaluate how far the technology has come to, and some of the very well developed pancake type motors are very impressive. In other words, I don't think if we try to develop every technology core elements ourselves, it's going to take too long. It's going to take too much money. And I like to borrow the best brain, best product, best technology out there and put it to, make a best balanced design for certain missions. And battery is the same thing. I've been working with battery folks, a while, and monitoring what's practical, what's down the pipeline. Same thing, I'm very eager to see when a hydrogen range extender will be ready, suited for certain missions. It may not be the just range extender. It may be the smaller battery pack with a bigger hydrogen system. But I try to make provision for all that. In other words, the wiring data systems and the control system is such that not 100%, but almost plug compatible. You can bolt on different modules for different design or missions. Yeah. So try to leverage the best brain, best product out there. Best resources out there. Yeah.
For sure. Well, Danielle's going to sell you on some hydrogen. So
I'm sure she will. I'll take
she's
it.
She's going to give you a couple fuel cells to put on board. And you know,
No, I
one of the
totally
challenges.
am. I would have chimed in earlier, but I'm eating. But that was a very fascinating presentation. Thank you.
Yeah,
You know, real
welcome.
quick,
Thank you.
one of the challenges with fuel cells is they just create an unbelievable amount of heat. So you have to be thinking about radiators and where to put them. But you've got these, you know, these external rotors that could potentially be good heat dissipation tools as well if you've got a way to.
Exactly. That's why the module bay I have for provision for hydrogen system is on the back side, right under the main rotor. So we
Okay.
can design the cooling system more effectively. Put it that way.
Yeah.
Yeah.
Yeah. Right. You're your own cooling fan.
That's right. But one thing I learned on many of the power plant installation on the airplane is that the internal drag is as bad as external drag. So anytime we design a cooling system, we need to optimize it as much as we optimize the external aerodynamics. Yeah.
I see what you're saying. Right. You don't want to take a big penalty for cooling.
Cooling drag is drag. It's energy. Right?
Still, right. That's right. Interesting. And then your wing and ground effect vehicle is amazing. You know, it says a lot about you, Johnny, that you designed this and thought immediately of saving lives and helping people to be rescued. I saw it and I was like, oh, good. That I'll use that as my yacht and my vacation home.
Actually, when there's when we have, let's say, 2 dozen of those parking around the world, we could select the better locations, and the yachting activity we treat it as operation training. How's that?
That's brilliant. That's brilliant. I'll come visit you in your Maldives headquarters.
There
That's
you
my
go.
promise to you
Yeah.
because
How do you know
because I
that
want to
we
help.
one of the headquarters? Yeah.
Just I listen to the clues.
There you go.
So do I, and I just got a clue.
I think try to convince enough relevant people to make it happen. Yeah. I try to do some engineering homework to say, okay, this is not a totally wet dream. It's at least technically feasible, and see how far we can push it.
Well, your aircraft, the redundancy you've built into the aircraft really resonates with me. I mean, if you had those 4 directional rotors big enough, they could almost back up, you know, in an emergency
Yep.
at 150 or 200% power, back up your mains.
Yep, that's exactly the intent.
Brilliant.
I mean, it makes sense because really today's motor technology, you make it twice as powerful as you really need. For one thing, it operates normally at the low setting. Yeah, maybe slight efficiency hit, but it doesn't add that much more weight or cost.
Right.
It adds
Right.
some, but that's well worth it to be having the extra redundancy and safety built into the design. Yeah.
Yeah, and you don't want to be
100%.
running them at 20% of what they're comfortable with, so it's nice and easy for them.
Exactly. It'll last forever.
Yes, exactly. Brilliant work, Johnny.
Thank you. All right. Anybody else have any thoughts? And actually, tell you what, if you guys think about it, I'll be happy if you guys can call up, send me an email, we talk more. I mean, I love to brainstorm more about, what's practical, what's possible, and so on. And with that, I think we're at the end of our hour. So, hey, thanks guys for listening to me talking about this. I mean, I love this stuff, so you guys know me. Be really delighted to talk to you guys more about the possibilities.
Well, well done. I would love to sell both of these, so keep me in mind when you need a business development guy. I'm here for you.
There you go. You are. Thank you.
Nice work, Johnny.
All right. Talk to you guys later.
Thank you, Johnny.
Thank you. Bye-bye.
Thank you. Bye-bye.